Okay, for this video, we're looking at complex numbers, and there's a special, to start off complex numbers, there's a special number I, and it's defined to be the square root of -1, because you can't take the square root of a negative number in the real number system. So when you square I, you get the number -1. So these two, when we're looking at complex numbers, are going to be very important to remember. So when you write a complex number, it will have a real part and an imaginary part. So I stands for imaginary. So the A and the B are just real numbers. And this I is the square root of -1. So if I have 3 plus 2 times I, the real part is 3, and the imaginary part is 2, not 2I. The imaginary part is the number multiplied by I. So if you have something like that, that is not simplified. We don't leave negative signs inside the argument. So we're going to use this rule here. How do you get a negative sign out of the argument? It will become an I. Okay. Now we want to be able to simplify. So that's as far as we can take these. But if I have something like that, okay, I can get rid of the negative sign. But this can be further simplified because the square root of 16 is 4. And I times 4, we're going to write that as 4I. Okay. Similarly, if I have something like that, now what you can't get confused is if you have a parenthesis, then the negative signs cancel and you just have that. Now that is not the case for what we have here. This negative symbol can't just come inside like it can with a parenthesis. This is going to be, the negative sign stays outside, and then this part is going to be I, and then we're going to have that, and that would be written as -3I, something like that. So if we scroll down here, the biggest mistake people will make with this kind of thing right here is they'll say that the negative signs cancel, and they do not. That is a square root symbol. That's not a parenthesis. Okay. All right. So suppose I want to add and subtract complex numbers. Well, what you do is you treat the I as you would an X. So let me get onto a blank page. Okay, so if I had if I wanted to simplify that, well, I don't have anything in the front here. I've got nothing in the front there, so I can just drop the parentheses. I would gather my x terms. 3x plus 5x is 8x. And then 2 minus 1 is 1. And I would have my answer. And so that's how, when we're adding or subtracting complex numbers, that's how you treat the I, like you would with the x. So let's have a look at these. And I'll copy them over here, and we'll just do these out. So let me make these bigger. Okay, so let's look at part A first. There's nothing out the front, so I can just drop it. There's nothing out the front, just a plus sign, so I can drop that. Now we want to put it in standard form, so you're going to want the real part out by first. So I just want to get the real numbers by themselves. 3 minus 2 is 1. And then negative 4i plus 7i, well, if that was an x, minus 4x plus 7x would be 3x. Negative 4i plus 7i is 3i. And then that's our answer. It's in standard form. So the real part is 1, and the imaginary part is 3, not 3i. Okay. And now if I look at the part B, if I'm going to add there's nothing out the front. Now there is a negative sign out the front, so if I distribute the negative sign through, negative 2 is plus 2, and minus 7i. Then we get the real part. 3 plus 2 is 5. And negative 4i minus 7i is negative 11i. And so that's my answer in standard form. The real part is 5, and the imaginary part is negative 11, not negative 11i. Okay. So that's how we would add or subtract complex numbers. Let's go back to what we have next. If I want to multiply complex numbers, I'm going to FOIL the same way as I do with real numbers. Just remember that I squared is equal to negative 1. Okay, so let's find each product, which we will do together. Okay, over here. And let's make that bigger. So so I'm going to FOIL just like we always have. We're going to start here with 2, and we're going to do that. So over to the side here, we have to remember I squared is equal to negative 1. Okay, so if I FOIL this like we have before, 2 times 5 is 10, and 2 times 7i, well, 2 times 7x is 14x, 2 times 7i is 14i. And then I'm going to come here, and I'm going to multiply that by those two. And so negative 3i times 5 is negative 15i. And negative 3i times 7i, well, do the numbers first. Negative 3 times 7 is negative 21. And then you have I times I, which is I squared. Now, 14i minus 15i is the same as you would think of 14x minus 15x. You'd have negative 1x or just negative x. So 14i minus 15i is minus I. Now I've got negative 21 times I squared, but I squared is negative 1. So I'm going to have 10 minus I, and negative 21 times negative 1 is plus 21. And then 10 plus 21 is 31. That's my answer. So the real part here is 31, and the imaginary part here is negative 1, because technically that's how you would write it if you want it in a plus b times I. But if you just type in 31 minus I into WebWork, it should be fine. So let's do a quick check. Come over here. Here we are, 31 minus I. Now let's look at the second one. All right, so this one can go. And let's look at this one. All right, now again, we want to remember that I squared is negative 1. Now, what this is not, what you cannot do is 7 squared minus 3i squared. It's not that. What we have here is 7 minus 3i squared, so it's 7 minus 3i times itself. And I'm going to FOIL this exactly the same way as I do for real numbers. 7 times 7 is 49. 7 times negative 3i is negative 21i. Negative 3i times 7 is negative 21i. And negative 3i times negative 3i. Do the numbers. Negative 3 times negative 3 is positive 9. And I times I is I squared. Or you can get confident, you can skip writing I squared and just write times negative 1. If I combine those, that's going to give me negative 42i. And then I have 9 times negative 1, which will be negative 9. And 49 minus 9 is 40. And this is going to be my answer in standard form. The real part is 40. The imaginary part is negative 42. And let's compare it. Make sure we got the right answer. Here we go. Right there. 40 minus 42i. Okay, and now for this last part, let me clear this. All right, so again, we want to remember that I squared is equal to negative 1. What I would do is leave this on the outside and do this foiling first. That's what I would do. So I'm going to leave the 2i on the outside. And I'm going to do inside these brackets first. Well, I might just give them a square bracket. Let's just leave curly brackets for sets. Okay, so do the foiling inside the square brackets. So the 2i's coming along for the ride, not doing anything to the 2i. 3 times 3 is 9, and 3 times negative 5i is minus 15i. Now let's get to the blue. 5i times 3 is 15i. And 5i times negative 5i, well, 5 times negative 5 is negative 25. And then I times I is I squared, which is negative 1. So the 2i's coming along for the ride. I'm going to clean up everything inside here. Notice I'm going to have a 9, and then I have minus 15i plus 15i. They cancel. Then negative 25 times negative 1 is plus 25. So that's going to give me 2i times 34. And 34 times 2 is 68. So my answer should be 68i. Now, in proper standard form, so the real part of that is 0, and the imaginary part of that is 68. Notice if you have a number, a real number, you can write that as a complex number. Okay. And so we have an imaginary number by itself, and I can write that as a complex number as well to get it into that standard form, a plus b times I. All right, so I got 68i for that one. Let's go and see what, there we are, 68i. Now, what happens? Now we should be able to handle if we're told to solve something with a quadratic formula and we get an answer that's not a real answer. So let's, suppose we have something like this, or another way you could, it could be asked would be to find the zeros of f of x equals that, or y equals that. So that's the same question. Find the zeros of that. So we can do that using the quadratic formula. so let me copy this and we'll put that over here. All right, and again, let me make that really big so we can see it. Okay, let's find the zeros of that. So that's the same thing as telling you to solve, i.e., in other words, solve x squared minus 4x plus 13 equals 0. So you can use a quadratic formula. A is equal to 1, B is equal to negative 4, C is equal to 13. So the solutions, or the zeros, are going to be x is equal to negative b, negative negative 4, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So let's clean it up. The negative and negative 4 is positive 4. Negative 4 in parentheses all squared is positive 16. And 4 times 1 is 4 times 13. So that's going to give me minus 52. And let me just do it like this first. All right, so I'm going to have 4 plus or minus negative 36 in there. Now I can split this up into two fractions. Now 4 over 2 is 2. I still have the plus or minus. Negative square root of 36, square root of negative 36 is going to be, well, let's get the negative sign out. So it's an I. And the square root of 36 simplifies to 6. And so that's going to be 6i. And 6 divided by 2 is 3. So I have two answers. Now there is no plus or minus symbol in web work. In web work, you have to write it as two separate answers. And so one of the answers is 2 plus 3i, which you can type in from your keyboard. And the other answer is 2 minus 3i. There is no symbol for this in web work. So you cannot type it in like that. You have to give it as two separate answers. Okay. So as we saw, the discriminant was negative 36. The discriminant was negative, and so there are no real solutions. We only have non-trivial complex solutions. So that finishes this video, and so now you should be able to do your lab problems.